Hi guys, today a quick one about Java Interop from Clojure. It could be a bit confusing for beginners, so today we'll cover all the cases, how you create classes, instances of classes, how you call methods, static methods, etc. And at the end we'll do a live exercise trying to convert some code snippet into some Clojure code. So let's get started. I prepared a project with a couple of examples, and we start with actually importing our Java classes into our Clojure namespace. So as you can see, I already have it here. Instead of require that we use for Clojure namespaces, for Java classes we use import, and then it will be an list, and then the first bit will be the path, the class path, and then the name of the class separately. So for me, it's still, struggling to remember that. Although I was working with Clojure for like 10 years or so. So what I usually do, I just rely on my IDE to help that with that. So let's say I want to remove this thing, and now if you're in cursive, you'll see this underline, and you can just do this, and that's option enter for my key bindings. It could be something else for you, but yeah, let's see, let's do it again. Import class, that's my, it's quite small, but you can see the binding for me. Basically, you do import class, and cursive will help you to do the correct import. That's how I usually do it. So here we can see a couple examples. So we'll use this D for date in a sec. So here we have an example of calling a constructor for Java class. It basically same as doing new date, something like that. Oops. So if I call this, now have D available. Again here, example of calling static method, and here as well. So that will I just execute it. We'll need those things later. So let's move to calling instance methods. So first example is we want to call toString on top of date instance, and that's the date class from the Java util. So the syntax is this: we open our as expression, and then we use dot in front of the method of the Java class, and then this argument is actually instance of the class that we executing the method from. So this Java line will be this line in Clojure, right? So as you can see already, the dot at the end of something will mean calling the constructor of the class. The dot in front will be the calling of the method of an instance. So this is an example. We're doing toString on the D, on the date. We're getting the result back. And the other method, get time, we're getting something back. And here, slightly more complex example. Let's see how it translates into Clojure. So first of all, today is our local date that we created right here. So it's instance of local date. IsAfter is actually a method of the local date, right? But then before we had no extra arguments, so it was calling method without passing anything to that. Here we have one argument. So any arguments will go after the instance of the class that we're using for the method call. So in this case, we're trying to create a new local date off, and then that's again example of calling a static method. We'll cover that in a sec, but that basically this slash, and then we pass some prompts there. So again, I can execute just the internal bit, this one, it will create a new local date, as you can see, right here. And then if I call the whole expression, it will be true. All right, next we're moving to calling static methods. We already kind of covered that, but basically you use the class name, and then instead of dot, we do slash and the name of the static method. So if we go inside, you can see that this is public static method from the math class. And again, you pass any arguments inside. So we have 4 here. And then another example, getting the system property as well. This is a static method. We want our operation system name. And as you can see, I'm on macOS. All right, so here for accessing fields. So sometimes we have public static, and then we have just some field inside the class. So you can use the same kind of way how you can just get the value of that field. So you can just execute that and get the value. For example, for the P from math, we're getting this. Chaining calls. So here 2 options, and I actually prefer the second one with threading from Clojure. But as you can see, in Java we can just do ... to chain the method calls. In Clojure there is double dots that will translate it to kind of this same form. We can call this, and that's the result. I'm not sure why. I'm not using that too often, but as you can see, IntelliJ is not happy. IntelliJ in cursive is not happy with resolving these names, and I'm not quite sure why. Basically, usually just use a threading macro from Clojure to chain the method calls, and it just works really nice, and I enjoy how it looks, and I can really easily understand that. So a reminder of threading macro is basically getting the first form, and then that result will be placed right here as the first argument in the second call, and then the result of this line will be placed right here in this first argument in this function call. As you can see, it just works with not just Clojure functions, but you can just use the methods from Java class, and it kind of will compile, because here it will get the instance of this local date, and everything will be passed down the chain of the calls. So if I just call that, I can see it works like this. So yeah, I would suggest just use threading macro, to be honest. Then we have slightly less frequent use case is to creating the arrays. There is a specific function to make array, and then you can say that array of type string. So we're getting the array, and then we have like a set of functions like aset, alength, aget to work with primitive arrays from Java. The other thing is implementing Java interfaces. One way to do that is to use the reify macro, I believe. Yeah, it's macro. And then it works like this. The result of that will be an instance of the implementation. We do the reify. The first thing here is actually the name of the interface we want to implement. In our case, a simple one called callable from current. And then you basically just define the methods that you want to implement. So if you go here, you see the signature, it's call without any params. So we name it the same. Then we need to provide a single param. And actually, sometimes you see something like people call it this, because even you don't see any params here, in reify, it will expect the instance of the class that we're trying to create as the first param here. And sometimes it's useful because if there is some state in your class, you can access here if you want that. It's fine to use underscore or sometimes underscore this to make the linter happy or whatever. But let's stick with underscore. So if I call this, I now have the something in C var, and it will be implementation of callable. And now we can just use our way of calling instant methods on the newly created instance right here. So I call this, I'm getting the hello from Clojure as the output. And then we have an interesting example of that I got from the official Clojure website today about type hints. So basically type hints, it's something like this. It's a metadata that you can provide on top of your definition of your argument and saying specifically to Clojure that this value, like the value inside X will be a string. So it can save the reflection, trying to define the type and what method to call. And what we're trying to demonstrate here is that it could be used to reduce some performance bottlenecks. So what we do here is we're creating a rather long sequence of strings like this. We just repeat how much is it, like 1,000,000 times the string, and then we mapping that through, and we do get length. So let's see the length of the string, and we have two functions, len and len2. And here in this first one, we don't have any type hints, and here we have exactly same implementation, but we just have additional type hint saying that the X is string. Let's execute this and see the result. So here we go. Maybe one more time, just see if we have different. So you can see it's just like, second and a half, 2 seconds for a cold start. It's probably safe to say that it will be around second and a half-ish. And now let's compare with the second variant with a type hint. Just call it a couple times. As you can see, it's just 100 milliseconds. So it's quite significant improvement in terms of performance. So if you're do some operation on a huge collection and you have performance issues, maybe you can throw a bit of type hints here and there and improve your overall performance significantly. That's the first use case for the type hints. The second one is actually what I'm using more often, is to make the IDE happy. So sometimes it's not allow you to go to definition of your method call because it's not quite sure which exact one you're trying to call because it's not doing the reflection of the types. In this one, we kind of happy to go to any of those, but as you can see, if I trying to go to definition of this one, it just gives me a list of variants, and you can notice that they are from different Java classes. To fix that, let's say I know that S should be string, I can just add a type hint right here, and now if I just go to definition, it brings me straight to the string Java class. So yeah, that's the use case for that. And next one we have the varargs. Could be really confusing for beginners in Clojure. But basically, if you see something like this in your Java class definition, these 3 dots here, that basically means in Java that this param could be a single instance, a single element, or more than one. So you can call get, you pass the first string, and then you can pass more arguments, and that will be valid in Java. You can think about using Clojure vector to do that, or just remove that and call it like this. Unfortunately, that doesn't work. So if I execute that, there'll be a class cast exception on the method call. Persistent vector cannot be cast to class, and that's actually how you will see in logs that it's like an array of strings with this bracket here. To fix that, we need to create a primitive array, and to do that we do into array, then you say type of that array, and then you provide your persistent vector, and it will be converted into array. So if I execute this, we see that we have some object. It's actually an array, and then if I call my function, I'm getting the pass now, and it just works fine. And at the end, before we go to our exercise, that's the notation, probably the most the ugliest one from everything that we've seen before, is how you refer to inner classes or inner interfaces in this case. So inside a map in Java, we have a map entry, which is like a nested interface. And to do that, you just add the dollar sign in the middle, and that's how Clojure understands what you want. Again, for the import, you just use the same name right here to import that. In Java, it will be something like this, by the way, if you like map.entry. So yeah, I mean, I prefer how this looks, but I understand that the dot is kind of like reserved to specific things as we've seen, like constructor calls and method calls. So probably that's why it's not working like that. So yeah, you need to remember this. All right, so now what I have is I have a file called example Java. This is from one of the AWS examples, how you work with like some basics, how you work with S3. Our task will be just get those things and try to rewrite them in Clojure and see if we have any problems. So to do that, I have exercise Clojure namespace. Let me remove everything. And let's start from scratch. So let's grab this snippet first, move it here, comment it out. And so here we will create the S3 client. So let's say I want a function to build S3 client, no arguments. I want to add a let block because I want somewhere to define my params, like the vars. So we want region, let's say region, and class name dot something means that it's a static thing. So we want region, and our help, we need some help from IntelliJ. I want this one from AWS, and then slash, and it will be US East 1. Right, so that's fine. Actually, that's not a method call, so I just do this. Then what we have is S3 client, right? So again, same trick, you do kind of this and import it. You have nice Java import right here. So it will be, we want the builder pattern, so we get builder, right? And then you see we have a chain of nested, not nested, but just chain of Java calls. We can do that trick that I showed. We can do threading macro and then do dot region and provide our region. And I think we actually don't need let, right? So we can just do this, bring this back to the top form. And that's it. We then called dot build, and we translated our first kind of snippet. And I think that looks pretty neat in Clojure as well. So I want to, so the next one will be define list buckets, and let's use the Clojure way of naming things with kebab case. So the first argument will be S3 client, client that we got. And let's remove this and get our snippet for that method. Here we go. It's a bit weirdly formatted, but we can work with that. So first one is we call list buckets on top of S3 client. So let's do that. List buckets S3 client. Yeah, that works. But we can try to add a hint as well here, just to be extra safe. Yeah, list buckets. Then we probably want to, let's call it list buckets response. Let's move it here. What else we have? Then we have a list of buckets. How we get that? We're getting the buckets from the response. And actually, I think we can, again, chain that. So it will be a list buckets, right? Okay. So the result of that will be list buckets response. I think we can do something like this for now. Let's get a step back. So this will be our response, and S3 list buckets. Oh, sorry, it's not list buckets. It's just buckets, right? Buckets. Buckets on top of the S3 client, right? So, all right, here we go. And again, we can just use threading macro to make it a bit more pretty in Clojure. Let's move this inside. Right, now that will be just buckets, actually. Buckets. And what we want to do in that example, if we want to do map or actually do seek buckets, using do seek because we're doing the side effects. And here we do print line bucket name and name or get name. No, it's just name from bucket. And that's what I was talking about. The IntelliJ is just not happy with that because it doesn't know what type of the bucket is, like what's the Java type for that. We can fix that by getting right here, getting this name and saying that it will be our bucket from AWS S3 model bucket. Cool. So here we go. What else we want? I think that's it. It's all wrapped in try catch, so we can do that as well. So let's say here we want to add a try block. So everything goes inside, and then you do catch right here, exception name. We can ignore that. Oh no, wait, we will do something with that. Yeah, we'll get the error message. So let's import an exception. And For whatever reason, it's not helping with that, but it's S3 exception from the model as well. So let's try doing that. Just here, right? Yeah. And here we want to, let's say, do print line again, say exception, and then do what we have, AWS error details. So dot AWS error details on top of exception, and also get error message. So it will be like this. I think that works fine. And system exit. Let's just replicate that, but it will be example of the static method call, right? So exit 1. Right, I guess we successfully replicated the Java class, Java snippet that we had in Clojure, and it looks like this. I think that's not too bad. If you want to learn more, I would just suggest do some practice, get some Java code and try to recreate that in Clojure, and it will be really useful. All right, that's it for today. Have a nice day. See you next video. Bye-bye.